Example 6 says, suppose that the cost C of obtaining water that contains P% impurities is given by the function C of P equals 120,000 divided by P minus 1200. Part A wants us to find the limit as x approaches 100 from the left-hand side of our cost function, if it exists, and then interpret this result. So because plugging in 100 wouldn't make the denominator equal to 0, we can just plug in 100 for this left-handed limit. So C of 100 equals 120,000 over 100 minus 1200. So if we divide that, that would give us 1200 minus 1200, which is equal to 0. And so the limit as x approaches 100 from the left-hand side of our cost function is equal to 0. Now what that means is as we try to, or as we get less and less impurities out, so basically 100% means that it's just like the natural water and it's not filtered at all and it has all of its impurities. The cost of obtaining that water approaches $0. So the cost approaches $0 as the water is less and less purified. Or approaches an unfiltered state or something like that. Okay, so find the limit as x approaches 0 from the right of our cost function if it exists. Now, note that we can't just plug in 0 because it would make our denominator 0, and we can't do that. However, let's think about our function like this. So our cost function is 120,000 over P minus 1200. But let's ignore the 1200 part for right now. And let's just think that our cost function is 120,000 divided by P. Now, if we're approaching 0 from the right-hand side, that means our number is very, very, very small. So what if we plugged in something like P to be 1 over 1,000? The way that we would compute that is this is equal to 120,000 times the reciprocal. And that would be 120 million. So that would be the cost if we wanted the impurities to be 1 over 1,000%. Now, what if we plugged in an even smaller number? What if we plugged in like 1 over 1 million? Then what we would do is we would plug in, or sorry, excuse me, multiply 120,000 times 1 million. And as our P% gets smaller and smaller, basically the thing that we're calculating is just getting humongous. The cost is getting very, very costly, even if we don't ignore the 1200, because after this, we still have to subtract off the 1200, but it's still going to be some very, very large number. And so basically, what we are trying to say is this limit is equal to infinity. So that is our answer there. As we get closer and closer to 100% purified water, or another way of saying that is having 0 impurities, the cost is unbounded and goes off to infinity. Part C says, is complete purity possible? Explain. It is not. The cost is unbounded and goes off to infinity. example 7 wants us to find the limit as x approaches 4 of our function f of x, where f of x is defined by this piecewise function. So the piecewise function is 12 minus 3/4 x whenever x is less than or equal to 4, and x squared minus 7 whenever x is greater than 4. So basically, we're concerned what happens right at x equals 4 because that's where we're calculating our limit. And just a really rough sketch. Here's x equals 4. This is a linear function with a negative slope. So maybe that looks something like this. And this is a quadratic function, so it's going to be a parabola, and that's going to look something maybe like that. And our goal is to figure out, is the limit from the right-hand side and the left-hand side the same? So are these approaching the same value? And I'm not sure. And so we could figure that algebraically though. So the kid from the left and the kid from the right, are they approaching the same number? The way that we could figure that out is we could plug in 4 into this function, and we could plug into 4 into that function and see if they give us the same value. So let's do that. So 12 minus 3/4, instead of x, I'm going to write 4. And then on the other side, I'll put 4 squared minus 7. So 12 minus 3/4 times 4 is 3, and that simplifies to 9. And then this is 16 minus 7, which also simplifies to 9. So what that means is I've drawn this incorrectly, and a more accurate graph would look something like this, where this point here is 9. And so they are approaching 9 from both sides. They're connected. And so the limit as x approaches 4 of this function f of x is equal to 9. If we had gotten different values here, then that would have been a different story, and we would have had to have said that the limit does not exist. But again, I have these two kids, they're coming in from both sides, and as they're approaching the x value 4, their balloons are approaching the value 9.